Hi, everybody. Welcome to Lecture 19 in our series on the Trivium. That is the first three of the classical liberal arts: grammar, rhetoric, and logic. We are deep, deep, deep into logic at this point, and we'll be concluding in this and the next lecture. In this lecture, we will look at hypothetical arguments, and in the next one, we will look at inductive arguments. So here we're building on our discussion in previous lectures of categorical arguments, the categorical syllogism. Basically, a categorical argument has a single subject or predicate and predicate, whereas a hypothetical argument is built out of multiple propositions. So let's review a bit what we mean by these things. We have here the old phrase, mind your P's and Q's. As we learned, I think it was back in lecture 15, P and Q are the letters most often taken to stand in for terms in a proposition. So if P, then Q, something like that. We're going to need to use those in the case of hypothetical arguments in order to understand the structure of the argument, because we're dealing with so many different terms that the complexity requires that we use a symbolic language. Before we dive into the arguments themselves, let's just review where these arguments stand in relation to something we've already seen, and that's different kinds of propositions. In a previous lecture, we learned that there are three kinds of propositions, at least when we're talking about Aristotelian logic: the categorical, the hypothetical, and the modal. Categorical propositions have a single subject, a single predicate. They put them in relation to each other using what's called a copula, or a linking verb in form of the verb to be. Hypothetical propositions bring together different claims in either conjunctions, disjunctions, or conditional statements. Modal propositions concern modes of belief. It must be true. It might be true. That's a higher level concern that goes beyond what we're doing in this short series. So let's just review what we mean here by hypothetical proposition. So a conjunctive proposition, I'm just making the claim that both P and Q are true. And in order for it to be true, both P and Q must be true. A disjunctive hypothetical proposition is holding that either P or Q is true. Now, if it's an inclusive disjunction, it will be true altogether if either one or both are true. You can potentially have both of them be true, and a disjunctive hypothetical proposition would still be true. If it's an exclusive disjunction, then it becomes an either-or statement. Only one of the two can be true. But either way, you're dealing with or, and that's symbolized by the letter V in the notation there. And then finally, we saw conditional hypothetical propositions in the form of if P, then Q. So here the order matters, and the first term is called the antecedent, and the second one is called the consequence. This we've all seen already. Now, the thing is, our hypothetical arguments are going to line up with each of those three kinds of hypothetical propositions. So a conjunctive syllogism corresponds to or consists of conjunctive propositions, disjunctive syllogism for disjunctive propositions, and you guessed it, a conditional syllogism for conditional propositions. Now, as we'll see, the conditional syllogism is the most important of these three, and the one we're going to look at first and spend the most time on. Conjunctive and disjunctive arguments you also often hear used, but they're less prominent. So let's look at these conditional syllogisms. So these are arguments built out of conditional propositions. So in the case of, you have two kinds, pure and regular, right? Pure is less common, but we have an example here of it on the slide. It's called pure because all three terms, the major premise, the minor premise, and the conclusion, these are syllogisms, so they have three terms. All three terms consist of a conditional proposition. So in this case, we have, if tulips are plants, then they need water. And if plants need water, then they depend upon rain. So if tulips are plants, then they depend upon rain. You can see all three, both premises and the conclusion, consist of conditional propositions, and this is why it's called a pure conditional syllogism. This is less common. More common is what we call, appropriately then, regular conditional syllogisms. These contain both hypothetical and categorical propositions. Usually the major premise would be a conditional proposition, and then the minor premise and the conclusion would be categorical propositions. So here we have a kind of reframing of the syllogism that we've been working at throughout this whole course. If Socrates is a human, then he is mortal. But Socrates is a human, therefore he is mortal. So the example of this we've seen all the way up to this point in the course has always been a categorical proposition, but here we see the same argument expressed in the form of a regular conditional syllogism. There we go. Oh, those are categorical propositions, right? So it's mixed in a way. It doesn't consist only of conditional propositions, but it includes the major term usually, major premise usually as one of them. So some examples here, further examples. This is an example of a pure conditional syllogism, and let's build out this slide here. We're going to talk about how to symbolize these things, because this is going to be necessary, especially as we deal with more complex arguments, in order to discern their structure. If you get a lollipop, then you'll be happy. This is taken from Hauser's book, Logic as a Liberal Art, and Hauser talks often about lollipops in the book. If you are good, then you will get a lollipop. Therefore, if you are good, then you will be happy. Sounds nice. You can symbolize this in various ways. So Hauser proposes a first way here, using capital letters corresponding kind of willy-nilly to the first letters of the relevant terms. Here, if L, then H, if G, then L, therefore if G, then H. So this is a standard-looking kind of syllogism. You can also symbolize these in general form. So if Q, then R, if P, then Q, therefore if P, then R. So R there is a term also used, PQRS are the terms most often used for symbolizing logical propositions. Now, a regular conditional syllogism, that was a pure conditional syllogism, consists only of conditional propositions. A regular conditional syllogism has a definite structure, as we've already suggested. The major premise, as the first premise, is a conditional syllogism, and this is followed by two categorical. In fact, this is, I should revise this. The major premise is a conditional proposition, and the minor premise and conclusions are categorical propositions. So to see how to determine the validity of these arguments, because now we're going to look at the validity of regular conditional syllogisms, you need to think about these key terms, P and Q, and the words antecedent and consequent. So in conditional propositions, as we've said, the order matters. So the consequent is a condition of the possibility or necessity of the antecedent. So the antecedent is a condition of the possibility or necessity of the consequent, we should say. And so remember those terms, antecedent and consequent. Those are the key terms. And now we can move toward a discussion of the validity of these things. The question of their validity is going to be determined by four kinds of regular conditional syllogisms, because there are, in fact, precisely four kinds. You can affirm the antecedent. So remember, that's the P in if P, then Q. You can affirm the consequent. That is, you can say these things are true. P is true or Q is true. Or you can deny the antecedent, or you can deny the consequent. Now, as we'll see, each of these four possibilities corresponds to, well, it's either valid or it's invalid. In the two cases where it yields a valid conclusion, or rather where it constitutes a valid argument and yields a true conclusion, have Latin names, modus ponens and modus tollens. And the cases where the argument it yields is invalid do not have names. We're going to look at each of these four to understand how to assess the validity of these things. So here's the thing. So if P then Q, the first possibility would be say, well, P is true, right? So if P then Q, and then your minor premise basically would say, and P is true. So I'm affirming the antecedent. Here's an argument. Example. If you are good, then you will get a lollipop. And that's notated there. And this is from Hauser's book. If P, then Q. Minor premise, you were good. So what we're doing is affirming the antecedent. We're saying P is true. And the conclusion is, therefore, you get a lollipop. So here we've constructed this argument. What we want to know is the argument valid? That is, if the premises are sound, like those things we're saying are true in the major and minor premise, is the conclusion, therefore, reliably true? And the answer in this case is yes, this argument is valid. We'll have a short description paraphrasing Hauser's useful discussion of this point in his book. So this is valid. If the child fulfills the antecedent condition, P, child is good, then the consequent follows. And in fact, she does fulfill the condition, as indicated here in the minor premise. And so we say this is valid due to the rule modus ponens. Modus ponens. So if this were a more advanced class in logic, focusing more on symbolic logic, we would be calling out modus ponens all the time, right? If you have a statement like this conditional proposition, if P then Q, so long as you know P is true, you can automatically say that therefore Q is true. So usually we go very quickly through this and just say, well, that's true by modus ponens, and then move on to the next step of the proof. A second logical possibility is to affirm the consequent, as we see in this example. If you are good, then you will get a lollipop. Same premise, major premise. You got a lollipop. Okay, so that's the information I'm bringing to bear on this, right? I happen to know that, in fact, the child did get a lollipop. Therefore, I conclude you were good. Therefore, P. Right? So the question is, does this follow? Is this a valid argument? The answer in this case, as suggested already on an earlier slide, is no, this is not a valid argument. Why? Explanation from Hauser, paraphrasing, this is invalid. There are lots of ways the child could have gotten a lollipop, right? So just the fact that she got it doesn't mean by itself that she got it from being good. Maybe her parent was just feeling nice that day, or some aunt came by and gave it to her, right? Just the fact that the kid is holding a lollipop at the end doesn't let me conclude with certainty, not just with probability, but with certainty that she was good, right? That the antecedent, that is true. Thus, we can't know that the child was good, and thus the conclusion, therefore you were good, does not follow. Basically, there were lots of ways you could have gotten that lollipop, right? So you can't conclude, if you just happen to know, in our case here, that Q is true, that P is true. So there's no modus ponens in the other direction, right? Modus ponens, if I happen to know that P is true, well, then Q is true. Not the case here. If you happen to know that Q is true, you can't conclude that P is true. Another case here, a logical possibility, is to deny the antecedent. So I'm going to say that P is false. Our example, back to the lollipops. If you are good, then you will get a lollipop. Okay. You were not good. Therefore, you did not get a lollipop. So if P, then Q, and what the information I'm bringing to bear here is not P, right? I happen to know that I was not good. Can I therefore conclude with logical certainty that I did not get a lollipop? And the result here is that this is not a valid argument. And let's take a look at why it is not a valid argument. It's also invalid. The problem is the same as in the last example. There are lots of ways the child could get a lollipop. Just because she didn't get it in one way, specified by being good, right, doesn't mean that she didn't get it in some other way. We just can't know, right? So what we're really talking about here is the possibility of factors that are simply not included in the information we have. This is a way of being appropriately humble in our argumentation. You can't draw a conclusion like, well, I know for sure the kid doesn't have a lollipop. Maybe she found one. Maybe she picked one up. Maybe she got one for some other reason. All we know is that the antecedent in this case did not apply. So if she does have a lollipop, we could say we know she didn't get it because she was good, but we can't conclude that she doesn't have a lollipop. And our fourth and final possibility here is to deny the consequent. And spoiler, this has a Latin name, so it's got to be valid. This is, well, here it is. Here's the argument. If you are good, then you get a lollipop. Yeah. You did not get a lollipop. So we're denying the consequent. We're saying the consequent is untrue. Therefore, you were not good. Does this follow? Therefore, not P. And in fact, yes, this does follow. Let's take a look at the description here and talk around it a bit. This is valid. Since the child did not get a lollipop, we can know that none of the possible ways to get it worked out for her. No aunt, she didn't find it, not a sympathetic parent or something like this, right? And this includes being good, right? So the fact she doesn't have it clearly means she was not good, right? Because if we're holding that the major premise is true, okay, so we're trusting that, then she'd have a lollipop if she'd been good. Therefore, we can know that she at least was not good. Also, as it happens, she didn't get the lollipop in any other way. We say that this is valid due to the rule modus tollens. So if I have the proposition, if P then Q, and then I am given not Q, I learn the information I'm bringing to bear is that Q is not true, then I can conclude that P also is not true. This is our second kind of valid inference from a regular categorical, a regular conditional syllogism. So we've been talking about these conditional syllogisms. Remember, we saw there was pure conditional syllogisms and regular conditional syllogisms. We've been focusing on regular ones. Here, we're going to look briefly in conclusion at the first two kinds of syllogism here, conjunctive and disjunctive syllogisms, focusing on their validity. Let's look at some examples. Here's an example of a disjunctive syllogism. Right? So, either the killer wore red gloves or the red cat left a hair on the carpet. The killer did not wear red gloves. I'm bringing that information to bear on the argument. Therefore, the red cat left a hair on the carpet. Okay, so if I take it as the case that the major premise is true, and either one or the other has to be true, and I know that one of them is false, then this is basically just process of elimination, as we have on the slide here. Think of this as process of elimination. Here, the major premise is an exclusive disjunctive proposition. This means that only one of the alternatives it states can be true. So if we know that one of those alternatives, one of them is false from the minor premise, that's the information we're bringing to bear, then we can know that the other one is true as expressed in the conclusion. Therefore, Q, right? So if I know that P is false, then Q must be true. That is, if I take the disjunctive proposition in the major premise to in fact be true, as we're doing here. Now, conjunctive syllogisms are a little, there are two examples here we'll look at. Here's the first one. This is an odd kind of thing, right? So let's look at our example. Major premise. Houstonians are good and Dallasites are bad sports fans. So I want to thank Hauser, whom I understand is from Texas, for teaching me that the word for people for Dallas is Dallasites. Thank you. The conclusion from this is, therefore, Houstonians are good sports fans, right? So basically, if we play out that major premise fully, Houstonians are good sports fans and Dallasites are bad sports fans, right? So P and Q. I'm holding that both of those things are true. I guess this person is from Houston. Therefore, Houstonians are good sports fans. The syllogism looks odd because it has no minor premise, as we have here on the slide. It simply states that since both of the propositions stated in the major premise are true, then it follows directly that one of them is true. Yeah, if I say two things both are true, then it follows that each of those things is true. So this is not an argument that you'll hear very often. We just take it for granted. I mean, this is a kind of intuitive piece of reasoning. But there is an interesting twist here in the case of negative conjunctive syllogism. So take a look at this example, which does in fact feature a minor premise. So in this case, I'm saying not P and Q, right? It is not the case that both P and Q are true. The major premise here is you can't be a citizen of Texas and Oklahoma at the same time. The minor premise, you are a citizen of Texas. Conclusion, therefore, you are not a citizen of Oklahoma. So therefore, if P, and I'm concluding here, not Q. Let's take a look at this. This is a proper syllogism. It does have a minor premise, as we see. That's the second premise. The major premise denies that both P and Q can be true. The minor premise states that P is true, and therefore we can know that Q is false, since again, both can't be true. In a way here, this is analogous to a disjunctive syllogism, because when you say not P and Q, you're almost making an exclusive disjunctive claim, like either you are a citizen of Texas or you're a citizen of Oklahoma. You are a citizen of Texas, therefore you're not a citizen of Oklahoma. So this is similar to what we saw above. Friends, that's going to wrap up our discussion of hypothetical arguments, modus ponens, modus tollens, fun stuff. We're going to wrap up next time looking at inductive arguments and the various kinds that can be made, as well as the notion presented by Hauser at the very end of his book of intuitive intellectual insight. Thank you.